Right, we're going to look at one problem on this video lesson. So we're told that the graphs of f of x is equal to minus 4x plus 6 and g of x is equal to 9x minus 72 are shown. Right, and you'll notice that they haven't been labeled for you, so they haven't told you which graph belongs to which function. But you should be able to reason about each function to match it with its corresponding graph. So if you look at f of x, for example, that is a straight line with a negative gradient and a positive y-intercept. So its gradient is minus 4 and its y-intercept is 6. So it makes sense then that this line over here is the graph of f, right? It's got a negative gradient and its y-intercept is positive. Whereas if you look at this line over here, it's got a positive gradient, right? It's a rising line and its y-intercept is somewhere down below, right? It's some negative number. So it makes sense that that is the graph of y is equal to 9x minus 72. Positive gradient, gradient of 9, and a negative y-intercept of minus 72. And so you're asked to firstly determine the coordinates of a, b, and c. And this takes us back a bit to our section on functions. When you're asked to determine the coordinates of given points, you need to ask yourself what's so special about these points, right? So if you look at A is the y-intercept of f, right, of my graph f. And you could either just read that straight away from the equation. So you could say that, well, A will be equal to, we'll have the coordinates 0 and 6. Or you could say, well, since it's on the y-axis, I know that its x-coordinate is 0. And so the question we're asking ourselves is, when my input is 0, so when my input to the function f is 0, what is the output? So that would be minus 4 times 0 plus 6, and you'll see that that gives you 6 either way, right? And then if you look at b, what's so special about that? What kind of a feature is that? Well, that's the x-intercept of g. So what we know about it is that its coordinates are going to be something and 0. So the question we're asking ourselves is, for what input is the output of g going to be equal to 0, right? So we figure that out by saying, well, when is 9x minus 72 going to spit out 0 as its output? So 9x would have to be equal to 72, and so x would have to be 8, right? So the coordinates of b are going to be 8 and 0. When my input is 8, my output is 0. Then finally, what kind of a feature is C? C is the point of intersection between the two graphs. And so what we're saying is that for a particular input, the output of f is equal to the output of g. And what is that input? What is the input for which that happens? So when is this output, minus 4x plus 6, going to be equal to this output, 9x minus 72, right? And so if we rearrange our equation, so we'll have 6 plus 72, right? Add 72 on both sides, and 9x plus 4x if I add 4x on both sides, right? So that would be 78 is equal to 13x, and if I divide by both sides by 13, then x is equal to 6. So we know that the x-coordinate of this point would be 6, all right? And so what is the y-coordinate? I can figure that out by putting it into either equation. I should get the same output because it's supposed to be a point of intersection. So my output, when my input is 6, is minus 4 times 6 plus 6, which gives me minus 18. And if we test that in our other function, so when my input is 6 for the function g, my output is 9 times 6, minus 72. So that would be 54 minus 72, which also gives me minus 18. So it is indeed, that is indeed my point of intersection, right? Let's move on to the next question. Right, so here's a question. If A, B, C, D, okay, now I've just thrown off my naming convention completely. Okay, anyway, so if A, B, C, D, I just got lost in thought there. If A, B, C, D is a parallelogram, determine the coordinates of D. And remember that the naming convention for shapes is that we go in alphabetical order. So A, B, C, D would have to be, because this line has to be parallel to the other one, you'd imagine that D maybe is somewhere over here, right, in order to make a parallelogram. You wouldn't go this way, right, to get to D. You would have to follow a parallel direction to get to D, right? And the key thing is that your letters have to go in order. So you could argue that D could be a point over there, where you could have A, C, D, B, or I don't know how it would work, right? But the issue is that then you would have your letters wouldn't be in order anymore. They wouldn't be in alphabetical order. Cool. So D has to be somewhere in that vicinity up there, right? And so how do we find D? There's a couple of ways that you can go about it. Because we know that ABCD is supposed to be parallelogram, we know that the diagonals of this shape would have to bisect each other. So the midpoint of AC would also have to be the midpoint of BD, right? So if we can work out the midpoint of AC, then we know the midpoint of BD, and we can then work out what the coordinates of D should be. So let's do that as a start. So the midpoint of AC would be 0 plus 6 over 2. Y coordinate would be 6 plus negative 8 over 2. And so that would be equal to 3. And 6 minus 18 is minus 12. Over 2 is minus 6. Right? So that would be the midpoint. So already my diagram is off because my midpoint is above the x-axis when it should be below. Right? And so the midpoint of BD would have to be equal to the midpoint of AC, right? Since it's a parallelogram. And so then the midpoint of BD would be 8 plus whatever the x coordinate of D is over 2, and the y coordinate would be 0 plus whatever the y coordinate of D is over 2, and that would have to give us 3 and minus 6, right? And 3 and minus 6 is just the same as, well, 3 is the same as 6 over 2, and minus 6 is the same as minus 12 over 2, right? And so 8 plus something would need to give me 6, so the x coordinate of D would have to be minus 2, and 0 plus something would have to give me minus 12, and so the y coordinate of D would have to be negative 12. And so just to do a sanity check, so 8 plus negative 2 is 6, divided by 2 does give me 3, and 0 plus negative 12 is negative 12, divided by 2 does give me minus 6, so that works. Right, so we now know that the coordinates of D would have to be negative 2 and negative 12. And again, my picture is so very wrong, and that's because it's not to scale. Let's look at one more question. Oh, wait, no, before we look at one more question, let's look at another way that we could have done this question. So another way that we could do it with relative ease is we could think about kind of distance, right? So there are two things we know about, for example, BC and AD. We know that they are equal. Oh boy. So we know that this side is equal to this side, and we know that they're parallel, right? So we know that their gradients are equal. The gradients of these two line segments is equal. So if we can figure out, how much we rise and run to get from here, from C to B, then the same would have to be true to get from D to A, or maybe the easier way here is, because D is the unknown, to go from B to C, I'll have to rise and run like that. And so to go from A to D, I'd also have to rise and run the same way. So in that way, I'm making sure of two things. I'm making sure that their lengths are equal, right? Because if this if these two are equal to these two, then by Pythagoras, these two must also be equal. And then the second thing I'm making sure of is that because the rises and the runs are the same, I'm making sure that the gradients are also the same. So to go from B to C, I'm dropping 18 units and I'm running 2 units backwards, right? That's how I'm going from B to C. And so that means to go from A to D, I'll also need to drop 18 units and run backwards 2 units, right? So from 0, 6, if I need to drop 18 units, then I'm going to drop down to minus 12, right? That's going to change my y coordinate to 18 units less. And if I run backwards, that's going to change my x coordinate to negative 2, right? 2 less than 0. And that's exactly what we got the first time around. So that's another way that you could have approached the question.